Hi guys, do you have an MTH 2003 final in 2 weeks, in 2 days, maybe in 24 hours? This video was made specifically for you. In order to ace MTH 2003, you need to know the following 300 plus topics. Well, that's a lot of topics, but if studied efficiently, even less than 24 hours study could dramatically improve your results. I'm going to cover the top 10 most common topics that appear on Baruch MTH 2003 finals. Everyone procrastinates, it's absolutely normal. That's why we prepared a special last minute cram course that will prepare you for your MTH 2003 final within a super short period of time. You can access our last minute cram course by clicking the link in the video description below. Also, do not forget to subscribe to our channel and like our video. So let's do this. So the first topic is the line. We're gonna look at problem 1 from MTH 2003 final SP17. Alright, so here we got we need to find the slope of a line which is perpendicular to 3x minus 4y plus 1 equals 0. What is the first step? First step is to always solve for y. For that, I have to do the following: 3x plus 1 equal 4y. I'm pretty much moving 4y to the other side. Therefore, divided by 4, y equals 3 over 4, x plus 1 over 4. All right. So in this situation, we know that the slope of this line is 3/4. Now, what is the slope of the perpendicular line? Because that's what we're looking for. The slope of the perpendicular line is the negative reciprocal, so negative 4/3. The answer is a very, very simple problem. Let's move on. Second topic is parabola, problem 3 from the final MTH 2003 final SP17. So here, find the vertex of the parabola. Boom. The vertex of the parabola is just negative b over 2a. But let's do this in steps. Our typical quadratic equation is y is equal to ax squared plus bx plus c. So if you're looking at the existing y equals x squared minus 10x plus 13, a equals 1. b equals negative 10, c equals 13. So if I plug in negative b over 2a, it's going to be equal to negative b, so negative 10, over 2 times 1, which is equal to 5. So now I know that the x coordinate, the vertex is what? Vertex is just a point, right? So if you have a parabola, this is the vertex. This vertex will have both x and y coordinates. So we know that the x coordinate is 5. We don't know what our y coordinate is. But we know that A is not going to work, C is not going to work, D is not going to work. So it's either B or E, because these are the guys who have 5 for x. So now I just have to plug in x equal 5 into the original function. So y of 5, so I'm just plugging 5 for x, equals 5 squared minus 10 times 5 plus 13. 25 minus 50 plus 13. If you do the math, it's negative 12e. Next, circle. We're going to be looking at problem 4 from the final MTH 2003, final SP17. Let me change the color of the pen just to make it more fancy looking. So here we need to find the radius of this amazing circle. Boom. So what can we do? We have to group x's and y's together. We have to know that the equation of the circle is x minus h squared plus y minus k squared equals r squared, where r is the radius. So let me just rearrange. So x squared plus 14x plus blank plus y squared minus 2y plus blank equals 0. I have to substitute something for this blank here. What is this blank? This is, I'm taking this number right here, 14 over 2 squared. Here I'm doing the same thing. I'm doing negative 2 over 2 squared. But I cannot just add those two numbers, those two expressions to one side of the equation. So I have to add these two also to the right side. So here I have to do plus 14 over 2 squared plus negative 2 over 2 squared. Now 14 over 2 squared is 7 squared, which is 49. Negative 2 over 2 squared is negative 1 squared, which is 1. So here I got 50, right? So I get x squared plus 14x plus 49 plus y squared minus 2y plus 1 equals 50. And I know for sure that this guy right here is equal to r squared. Therefore, my radius is just square root of 50. And the answer is C. Next. Topic 4, horizontal asymptote. We're going to be looking at problem 5 from the final MTH 2003, final SP 17. We need to determine the horizontal asymptote. When we are talking about horizontal asymptotes, we are always talking about limit when x approaches infinity. It's the same exact thing. And there are 3 rules. If top is greater than bottom, then it's undefined. D&E does not exist. If top equals to the bottom, then it's difference of coefficients. So it's coefficient 1 over coefficient 2. I'll explain this in a second. And when top is less than bottom, the answer is 0. Now, what the hell is top? What the hell is bottom? I'm looking at the highest exponent on top and highest exponent on the bottom. What's my highest exponent on top? It's 1, because x is to the first power. What's my highest exponent on the bottom? It's 2. So I got 1 over 2. Clearly, top is less than the bottom. Therefore, my answer is 0, A. You know this rule, guys. You really know how to solve this problem. Super simple. Here, topic 5, limits. We're going to be looking at problem 11 from MTH 2003, final SP 17. We need to find the limit when x approaches 3 of x minus 3x squared plus 4x minus 21. The first thing that you always do when you have x approaches something which is not infinity is what? Plug it in. You plug in x equal 3. So here you get 3 minus 3. That's the first thing you do. 3 squared plus 4 times 3 minus 21. So on top we got 0. On the bottom we got 9 plus 12 minus 21, which is also 0. So 0 over 0. Now here's a trick. If you have something of the form 0 over 0, you know for sure that you can simplify it. So let's try to simplify top against the bottom. So the top stays the same, x minus 3. The bottom is turning into x minus 3 times x plus 7. To check that, just FOIL it out and you're going to get the same x squared plus 4x minus 21. So here I can clearly cancel x minus 3. So I'm left with 1 over x plus 7. And I still have the limit when x approaches 3. So if I'm plugging x equal 3 into this, I get 1 over 10. And that is B. Next. Continuity, topic 6. We're done with half the topics. Very fast. So here we're going to be looking at problem 12 from MTH 2003 final SP 17. We need to figure out for which value of c would the function below be continuous on the interval from negative infinity to positive infinity. What does it mean? It means that when x is equal to 5, this guy has to be equal to that guy. All we have to do is plug in x equals 5. So let's just do this again. We have x squared minus c. This guy has to be equal to cx plus 6. And it has to be equal when x is equal to 5. Well, where did I get x equal 5? Well, right here. The border. Whatever is the border, you just plug it in. So let me just plug in x equal 5 into this. So I got 5 squared minus c equals c times 5 plus 6. So I get 25 minus c equals 5c plus 6. If I rearrange it, I'm going to get 19 equals 6c. Therefore, c is equal to 19 over 6. The problems on continuity, the answer is B. The problems on continuity are always about plugging in whatever the border value is. Topic 7, economic functions. We're going to be looking at problem 6 from MTH 2003, final SP 17. So this is word prompts, all this stuff. So let's just take a minute and read this. So the demand function, demand right here is 100 minus 2x. And where x is the number of items demanded and p is the price. How many items should be sold to maximize revenue? There are two things here. First of all, what the hell is revenue? Second is, what do I do with this whole max-min thing? Maximization, minimization. So I'm going to give you a formula for revenue, but for maximization, minimization, if it's maximum, minimum, highest, lowest, most handsome, most ugly, whatever, you always take the first derivative. Always the first derivative when it's max or min. But before you take the first derivative, you have to take the first derivative of the revenue. In order to get that, you need to get to the revenue. So revenue is equal to demand function multiplied by x. So revenue in this situation will be equal to demand, which is 100 minus 2x times x. So this is 100x minus 2x squared. Now it's time for us to take the first derivative. So r prime is equal to 100 minus 4x, and you set that to 0. Therefore, x equal 25. So they are asking us how many items should be sold to maximize revenue. D, 25. Next. Topic 8, derivative. Problem 8 from MTH 2003, final SP 17. Here, we need to find f prime of 2 of this function. There are two ways to solve this specific problem, and I will show both ways. The first way is to use the quotient rule. The quotient rule goes like this. Why is it quotient? You have one thing divided by another thing. So if you have f over g prime, that thing is equal to f prime g minus fg prime over g squared. All right? So for that, we have to identify f equal x plus 1, which is our top, and g is equal to x, which is our bottom. So therefore, f prime is equal to 1, and g prime is equal to 1. And we just plug it in. So f prime is 1 times g times x minus f, which is x plus 1, times g prime, which is 1, over g squared, which is x squared. So this is equal to x minus 1 over x squared. This is equal to negative 1 over x squared. We're not done because we have to plug in f prime of 2. So f prime of 2 is, I'm just plug in 2 for x, so it's minus 1 over 2 squared, which is negative 1 quarter. D. So this was the first solution, the first way of solving this specific problem, where we had to use the quotient rule. But there is yet another way, potentially easier way to solve this problem. So let me just erase everything. I will change the color so that it's not purple, but something else. So let me just erase this. It will take some time. All right. So while we know already that the answer is D, right? And here we had to do the quotient rule. Here, another way is to identify the fact that you can actually divide this given fraction, split that given fraction into two fractions. So let me start. So if you have x plus 1 over x, here you can say that this is equal to x over x plus 1 over x. You can do this, of course. So this is equal to 1 plus 1 over x. And let's rewrite this as 1 plus x to the negative first power. This is our f of x still. So we did not do any derivative. This is still the original function. Now, in order to get the derivative f prime of x is going to be equal to 1 minus 1 x negative 2. And obviously I messed up because the derivative of 1 is 0, so it's just 0 minus 1 times x negative 2 to the power of negative 2. So this is negative 1 over x squared. And then you do the same thing, f prime of 2 equals negative 1 over 2 squared, which is negative 1 quarter. Much faster way, much less confusing way, but you just have to, for this one, you unfortunately have to recognize that you can split this into two fractions. Next, topic 9, chain rule. The chain rule for problem 15 from MTH 2003, final SP 17. Here we got the square root of x squared plus 1. Now, why is it a chain rule? We need to find the derivative. Why is it a chain rule? Rule of thumb goes like this. Something, whatever it is, something to a power, if you have that and you need to find the first derivative, you have to use the chain rule. Now, do we have something to the power? First of all, let's simplify. Let's rewrite it. So this is x squared plus 1 to the power of 1/2. So now we got something to the power. Boom. Now the chain rule goes like this. Is if f of x is equal to u to the power of n, then f prime of x is equal to n u n minus 1 times u prime. In our situation, let's rewrite. F of x equals x squared plus 1 to the power of 1/2, right? So our u is equal to x squared plus 1. Our n is equal to 1/2. What is our u prime? U prime is equal to 2x. So therefore, if I'm to take f prime of x, I gotta get, now let me just, not to confuse you, let me actually use some colors. Let me use, like, say, blue color. So I'm looking at this, right? So it's n, which is 1/2, times u, which is x squared plus 1, to the power of n minus 1, right? So it's 1/2 minus 1, right? So 1/2 minus 1 is negative 1/2. So negative 1/2 times u prime. U prime in this situation is 2x from here. So now I have to properly rewrite it. It's 1/2 times 1 over square root of x squared plus 1 times 2x over 1. Here I can cancel the 2's. So I have x over square root of x squared plus 1. That's my final answer. It is D. D. Okay? So that's the chain rule. And last but not least, horizontal tangent line. This is from MTH 2003, final SP17, problem 7. So here we got, find the point where the graph f of x equals negative 4x squared plus 32x minus 10 has a horizontal tangent line. For the horizontal tangent line, all you have to do is, there are 2 steps. First step is find the first derivative. Second step, set that derivative to 0. And then the third step is to plug in whatever you got from step 2 into the original function, f of a, right? All right, so let's go. So f prime of x equals, we're looking at this function right here, it's equal to negative 8x plus 32. Set that to 0, x equals 4. Immediately, this is 4, this is 4, this is out. So it's either a or b. And now we have to plug 4 into the original function. So f of 4, not into derivative, into original function, is equal to negative 4 times 4 squared plus 32 times 4 minus 10, which is equal to negative 64 plus 128 minus 10, which is 54. So it's A right here. Okay? We covered the top 10 most common topics that appear at Baruch Math 2003 finals. Again, everybody procrastinates. It's absolutely normal. And that's why we prepared a special last-minute cram course that will prepare you for your MTH 2003 final within a super short period of time. You can access our last-minute cram course by clicking the link in the video description below. Also, do not forget to subscribe to our channel and like our video. Thank you. Bye-bye.